Hello everyone, myself Janvi S, Assistant Professor, Department of CSE TSATM. I am a video researcher scholar under the guidance of Dr. C. Nandini, Vice Principal, Professor and Head of CSE Department, Dana Sagar Academy of Technology and Management. I am presenting a paper with ID 60 titled Multifold Secured Bank Application Surveys using random issue cryptography and multimodal steganography with blockchain technology in the International Conference on the Recent Trends in Machine Learning, IoT, Smart Cities and Applications. Coming to the agenda, the PPT has flow starting with the abstract introduction, motivation, related work, multimodal mass technography, and random visual cryptography, working principle, how to incorporate with blockchain, conclusion, and references. Coming to the abstract, as we move towards digitization, where services are made online, to access application like banking application, we need to give credentials than traditional way. Biometric features are given to authenticate the user. During this process, when we communicate biometric data over internet, there is a chance of hacking the credentials. So to ensure a secure channel to communicate biometric data, random access cryptography and multimodal steganography is used with blockchain technology. Coming to the introduction part, the biometric features like face and fingerprint captured for authentication is embedded in a cover image using a mask image, before which the cover image is divided into four subbands. The data is embedded in these four subbands. The resultant stego image is given as input to random visual cryptography that creates shades which are color shades. We will see in detail in coming slides. The shares of a particular user is communicated as blocks using blockchain technology. The server at the other hand checks the data for authentication. Coming to the motivation, the biometric data can be hacked that leads to personal or business loss. Hence, need a secure way or mechanism to communicate data over the internet during authentication. Coming to the related work, securing image with fingerprint data using steganography and blockchain. The author has designed a system to improve the transparency and non-repudiation of photos uploaded in social media. First, user fingerprint is captured while uploading the captured photo. Fingerprint features is embedded inside captured photo at the server end, and the feature is extracted to authenticate user, and the photo is uploaded in social media. The same embedded photo will be stored in gallery if the user wish to upload later. Coming to the broadcasting steganography in the blockchain, from the transaction pool, a set of n transactions are chosen and rearranged so it corresponds to secret data in a block called stego block, which is considered as key. At the receiver end, the key is used to retrieve data from the stego block. Coming to the joint transaction image steganography for high capacity covert communication, which presents a framework where it has a hint to assess the information hidden in stego image. If the hint, that is, consists of partition number, image URL as a stamp matches, it is considered as stego block. Based on the access time, the stego image is swapped with normal image in cloud server. The image will be encrypted using RSA-AES algorithm before swapping. But this framework is a weak link to tamper data. Coming to this, where probably secure covert communication on blockchain, where the sender sends one bit per transaction by placing in LSB of transaction address. Needs set of transactions to send all data, and it is time consuming and cannot be implemented in real time. Hence, the sender should be aware of receiver address too. And coming to this slide, this is a working process of random visual cryptography and multimodal steganography. The face and the fingerprint extracted features are embedded in the cover image subbands using a mask image that is equivalent to each subband, where each subband stego image is given as an input to random visual cryptography to create shares. At the decryption phase, the shares are combined to get subbands, which in turn combine to get complete stego image using mask image. The embedded features are extracted. The result shows varying cover image, face biometric, and face and fingerprint data, evaluating peak signal to noise ratio. Structural similarity means square error. and correlation coefficient, yielding very good results. With the noise yields 30 PSNR, 62 MSE, 0.75 SIM, and 0.5 CC. Coming to the slide where how blockchain improve data security. Because of its feature that uses hash value in linking each blocks, any change in the block, the chain will break, which indicates the data is tampered. In general, what is blockchain or what is block in general? A block has a transaction data, hash value of the data in block body, hash value of previous block as block header in general. The shares generated are saved as blocks in cloud application of banking. The shares are encrypted using RSA and the private key is encrypted using DES. The server will provide the encrypted key that decrypts the shares, which are then combined to get the stego image to extract biometric features for authentication. Coming to the slide where first we receive the information initially and using the hash technique we generate the root hash and we encrypt information and generate the block body and we fetch the previous block root hash and then we generate block header using previous block RH with current block RH and with timestamp and with nulls. And then we merge the block head with block body using compression technique and generate the block. And we store the block in the cloud. This is how the block creation process works. In the block header and the body is created using following steps. In the block header, we generate the hash code for each and every file or information using hashing technique. Generate random value and then taking the timestamp and then if the block is first block, it stores all these values like current hash value, timestamp and the none in a string. Write the value inside the confidential file that is block name.txt. If the block is not the first block, then the previous block hash value and store all the contents inside the string value and write details into the confidential file. Whereas in the block body, we encrypt the information, add the encrypted information to the .zip file, to that .zip file add confidential file also. In the screenshots, the server is registered located at different location, so generate RSA private key. In the below screenshot, it shows where the registered server details which has server name, location and mail ID. The user register details can be viewed in the admin log. You can add, modify, delete user detail, Aadhaar card, names, location, mail ID, contact details. In the below screenshot, respective user's 12-digit Aadhaar card is considered to upload shares as the admin name. After uploading shares, the block created are shown in the cloud like a zip file in the application, which has creation details, size, and etc. If we try to download the block currently from the cloud, it will be having a block data and encrypted image. The block header has previous block hash value timestamp, 4-digit ones, and current block hash value. The server provides private key to assess users' share on successful key. The shares will be downloaded. If not, the server will send an intimation mail about change in the block data called smart contract. Hash value generated for the block, we can see the block hash value is tagged to the next block. It is observed with increase in block size in MB, the time increases to create block. We can see in this comparison of required transactions, highest capacity and capacity per transaction of existing and the proposed system, where in the existing system, joint transaction image technography for high capacity convert communication. For 1 kilobyte, the required transaction is less than or equal to 12, whereas in the proposed system it is 1. And for 1 megabyte, the required transaction is less than or equal to 24, whereas in the proposed system it is 1. And the capacity per transaction in the existing system is 29 bytes, bits, whereas in the proposed system is varies from kilobyte megabyte. Whereas the highest capacity for the existing system is 759 kilobytes, whereas in the proposed system it depends on the cover image, that is the size of the cover image. The virtual user are created using Ready API to measure the application performance. It is observed with increase in virtual user. The average response time increases, transaction per second in MB per second keeps increasing but gets stable at some point. The same is depicted in the graph in the next slide. Coming to the conclusion part, communicating biometric data securely over the internet to authenticate services is very essential since the services are made online. Authenticating user to access application is an important aspect in banking sector. With regard to this, biometric features, that is face and fingerprint, are embedded in the cover image using multimodal mask technography and mask image. The block contains shares which are encrypted using RSA. The resultant is then combined with the previous hash value, timestamp, nonce, and previous block hash value are stored as a single string in block. The resultant stego image is passed to random visual steganography technique to create colorful meaningless shares which are saved as blocks in the blockchain. Then just passing information over the internet to each server to authenticate user. The server accesses blocks by decrypting the key using DES and then applying the private key to get shares. The shares are then decrypted using random visual cryptography using to get stego image. The features of face and fingerprint are then extracted using multi-modal mask technography. The extracted features are then compared with the bank database to authenticate user. Hence, the biometric features using blockchain technology are tamper-proof since any changes in the block will be intimated to the server while accessing the block. The application performance is tested with transactions per second, average response time of an application with increasing the number of virtual users. And it is observed the response time gets stable with increase in virtual user and transaction per second increases with increase in virtual user. These were the references that has been taken by Cryptography. And thank you so much.